Hello, welcome to everyone in this video. This is lecture number 23. Before 22 lecture, actually we cover to the solution for the problem asked in the book, that is the electrostatic and magnetism by Bigos, right? By Bigos of this book, we already covered chapter 1, 2 and 3. Three chapter problem solution already covered in the previous lectures, and in this book, that is the DJ Griffith Electrodynamics by DJ Griffith. In this book we already covered, that is the chapter 2, and for chapter 3 we already covered the problem number 3.1 to 3.11. This portion we covered in the previous lectures, that is 22 lectures covered these three chapter of this book Bigos, and the chapter 2 of Griffith and chapter 3 this portion. And this, in this lecture we want to discuss about the problem number 3.12 to 3.19 of this book, that is the DJ Griffith of the electrodynamics, right? So this is the part of this problem set of of this book, that is the electrodynamics book, right? So go to the question, that is 3.12, which says that find the potential in the infinite slot of exercise 3.3 in the if the boundary at x equal to 0 consists of two metal strip, one from y equals to 0 to a by 2, 0 to a by 2, at a constant potential v0, and from y equals to a by 2 to a as a constant potential minus v0, right? So from equation 3.30 exercise 3.3 you will be get the 3.30 equation that says the potential is for that structure, this like of structure. Actually this was solved using the Poisson's and Laplace equation, mainly Laplace equation solved, and so after solving they got this relation, that is the potential at any point for this like of this like of structures, or the configuration, this like of configuration. The potential is like that: n equals to 120 cn e to the minus n pi x by a sin n pi y by a, where this cn is nothing but 2 by a 0 to a v0 y sin n pi y by a dy. Okay, this is equation number 3.34 of this book. Here the given the v0 equals to v0 for 0 to a by 2 and minus v0 for a by 2 to a. Now we can find out the value of Cn using this condition, that putting a 0 to a by 2 putting v0, and a by 2 a putting minus v0, that's why taken v0 as a common. This is positive and this is negative, and integrating sign is minus cos, and putting the limiting value you will be got this relation. Okay, will be got this relation, sin cos n pi is minus 1 whole to the power n, and these are written here. Now for odd n, that is minus 1 whole to the power n equals to minus 1, and for odd n this will be 0. So this is 0, this is minus 1, so totally Cn will be 0 for when n equals to odd value. When n equals to odd value, total Cn equals to 0. And when n equals to even value, if we take even value, minus 1 whole to the power n is 1, but this will be minus 1 for n equals to 2, 6. For 2 you can say this is pi, cos pi is minus 1. For 6 you can say 3 pi, this is also minus 1, right? And for if you put 4, that is 2 pi, this is 2 for 2 pi, this will be 1, and so on, right? So you can say this Cn will be this when this is so this if you take this value, we can see here, that is minus 1 whole to the power is 1, and this is minus 1, so this total becomes 4, that's why this is 8. And when this value, then this is 1 and this is 1, so this 1 plus 1 is 2, and this minus 2 cancel out. So only this combination, that is n value is 2, 6, 10, 14, this is the existing value for Cn, and the other value of n equal gives you Cn equals to 0, right? So only n equals to 4j plus 2, where j equals to 0, 1, 2, 3. You can see that 0, 1, 2, 3. the general form of this value, right? So for the n value only this Ca is present, and for others value of n Cn equals to 0. So you can see the total potential will be like that, where n equals to this, or in terms of J you can write down this equation, right? So just putting the value of Cn in this potential expression, right? So we go to the next question, 3.13, which says the infinite slot, these two are infinite slot, determine the charge density on the strip at x equals to 0, assuming the conductor constant potential. So this is the expression of this potential, and from equation 2.9 the charge density will be like that. So the charge density can be find out, this is normal, so the normal is along the x direction. So del del x at x equal to 0, the interface will be 0 at x equal to 0. So if you taking the derivative with respect to x, you will be get this expression within this x, and others is constant. So you will be get finally summation of this. Here you can see this will be the if n equals to only the odd value are exist, because for even value this equals to 0, right? You can see here this for even value this is equals to 0, only for odd value this actually exist, right? From here I think you can conclude that what is the okay. So 4v0, this is that written here, right? Here you can see when put x equals to 0, so this is 1. So finally we got this one. So actually this solution we obtain from this. So here initially these are n equals to odd value, right? So these are the initially from question number 2.49 we get this relation, and from exercise 3.3 equation 3.36 gives you this solution like that. Actually this type of solution obtained in this case in the book, you can refer to the book to obtain this solution in the same process. Go to the next question, which says 3.14, a rectangular pipe running parallel to z direction. This is rectangular pipe parallel to z direction, minus infinity plus infinity, has three grounded metal. These three plate are grounded, and this is having a potential, right? So develop a general formula for potential within the pipe. So we need to find out the potential within the pipe. So within the pipe there is no charge, so we can write down the Laplace equation for this region, and this Laplace equation is like that, and there is no z variation, we take the only these two. And you can see here the boundary condition, that is at x equal to x and y equals to 0. At y equals to 0 the v0 equals to 0, at x equal to 0 also 0, at y equals to a this is 0 only. When x equals to b and any y value, this will be y v0 y, function of y. So we can separate out by the separation method. Actually these questions lies on the separation of method, right? All the question are actually separation of variable portion question. This question are from separation of variable, okay. So if you take this separation of variable in partial differential equation, you learn in the semester 1, that is the partial differential equation. In this partial differential equation we can take these two as a independent variable. So if you when we derivative with respect to s, then y is a constant dx dt. This del become d, because this x is only function of x, right? This capital X only function of small x. Similarly second derivative will gives you like that, and in case of y this is also. So put these two expression in this expression and divided by xy, will we get this equation taking the separation constant, because this is a function only of x and this is a function of only of y. So these two are separate out. That's why we can say this is a separation method and take a constant. So this will be k square, and this is will be minus k square. So this gives you e to the power kx, e to the minus kx, and this gives you sine cos. So finally you got this expression, that is the solution. Now putting the condition, this is the potential expression. put this boundary condition at the first, the potential is 0 and x equals to 0. I think x equals to 0. This is a mistake. This is 0, not a. X equal to 0, if you put the value x equals to 0, y equals to 0, if you put the value y equals to sine 0 0, cos 0 1. So finally you got d equals to 0. So this is the expression. Now if you want to put the value that x a, which is 0, so x equal to x, y equals to a, putting, then you will be get the value of k. Now put this third condition 0 y, that is x value is 0 and this is y, so this gives you e plus f equal to 0. So f and e are equal and opposite. So finally we got this type of expression of vx, and in summation form this is. So you can take this is nothing but the sine hyperbolic x 2, this 2 and this combinedly getting this constant, and this is sine. So this is the potential expression for this. This is the potential expression for this distribution within this cube, right? Where Cn can be formed the boundary condition, that we actually use the three condition. From the fourth condition we can find out the value of Cn. We can find out value of Cn. What is with the condition? That is Vb equals to Vy, V0y actually. This was V0y, V0y. So if we put this value that Cn, and by Fourier, using Fourier transformation, this equals to 2 by a V0 into a by Fourier transformation. So hence the Cn, the coefficient value will be 2 by a sine hyperbolic this 0 to a V0y sine hyperbolic, sorry, sine n pi y by a, right? So this is the value of Cn, where potential given here, this is the value, right? Next question, find the potential explicitly for the v0 equals to v0 y equals to v0. This is the any function. When this is any function, then the solution will be like that. But when this is not a function, then we can say this if this is a constant, then we can find out this as a, because this is a constant, take out, and this integration will be cos, put the value, will be get this equation. For odd value of n, this is for odd value of n, this is -1, and for even value of n, this is 1. For even value, this is 1, so total is 0. For odd value, this will be 2, so this become 4, right? So the solution will be like that, the value of Cn, put the value of Cn, and finally we got this expression where n equals to 1 to infinity. But here the n is not all value, this is uh, odd value only. So this become 1 3 5 and so on. This is 1 3 5 and so on. This is 1 3 5 and so on. Clear? This is the solution. Go to the next question, which says that a cubical box site of A consisting 5 metal plates which are ordered together grounded. That means 5 are grounded. Only this one is not grounded. The top is made by separate sheet of metal insulated from other and held a constant potential. These have a constant potential. This plate has a constant potential, and others 5 plates are grounded. Find the potential in within this, inside this box. So we need to find out the potential into box. So the Laplace equation will be of it, and these are the boundary condition where you can say that x equal to 0, x equal to a, both potential 0. Similarly y equals to 0, y equals to a, potential 0. Z equals to potential 0, z equals to 0, potential is 0, but z equals to a, potential is v0, right? So these 6 are the boundary condition. Now this is the Laplace equation is written in the separate out and take the partial differential equation separation method. Put this value and divided you, and take this as a minus k square, this as a minus l square. So finally we got this will be z k square plus l square, and this is the solution of the z parameter. Okay, and whereas y has taken as a minus l square, so this is the solution of y. Similarly for x, this is the solution for the x. Now they put the value of x, y, z, you will be get this expression. Now we use the boundary condition x equal to 0, v equal to 0. So this v equals to 0, x 0 means this is 0, this is b. So here you will get got b equals to 0. Similarly at x equal to a, v equal to 0. So this will be a side cos this, and so from here will we get the value of k, that is the n pi, that is sorry, that is the n pi by a. Okay, so this is y equals to 0 and b equals to 0. Next condition, b equals to 0 at y equals to 0, will we get d equals to 0, and here you can see that is y equals to a, b equals to 0. Next condition, and from here will be get the value of l. So finally we got, and this from this expression you will be get f equals to minus e. So finally got this relation, you will be carefully calculate this one, and Vx finally got in the summation from this coefficient can be developed the boundary condition, we the last boundary condition, that is at a z equals to a, that v equals to v0. So this v0 equal to like that, if using this Fourier transformation, this constant is written as, there will be two summation, so that's why they are taken as a two integration, right? So if you calculate it, if n and m both are odd, then we will be get the value. If any one or both are even, then this gives you 0. Okay, so this mathematics actually skip, you can do this mathematics to satisfy this expression. So the value of c is equal to this when m and both are odd and even, this will be 0. So finally got the expression for the potential, we just put the value of c and m. Next question, 3.16 says derive P3x polynomial, uh, that is legendary polynomial. Uh, yeah, check this P3 satisfy. Sorry, derive P3 from the Rodriguez formula. Rodriguez formula is like that. Put the value L equals to 3, you will get this expression, and just derivative, three times derivative, first derivative, and the second derivative, third derivative. So you will be get finally this expression. Okay. So this is P3x or half Px and like that. Now check P3x satisfy the angular equation for L equals to 3. This angular, this is P3x. So the angular P3 cos x, this is P3x, so P3 cos x is just put the value of cos theta in present of x. So at the x point, the value will be cos theta. Equation 3.0, which says that that is d theta of sin theta d phi d theta equals to minus L into L plus 1 sin. So for L equals to 3, this is minus 3. So we need to prove this relation in case when this function will be this Lagrange function P3 cos theta, right? So if you put this value of P3 cos theta in this expression and just derivative, you will be get this expression, and then multiply this portion and then taken derivative, and just evaluate this expression. I think you can do this calculation, you will be get this equation. So this will be satisfied, this expression will be satisfied in case of the by in case of the Lagrange P3. Okay, P3 cos theta also satisfy. Then and there was a question that check P1 3 and P1 are explicitly integrated. Explicitly means they are independent to each other. So P1x is x and P3x equal to this. So if you multiply this and integrate it from -1 to +1, That is the limit of the legend Lagrange function. Okay, and after putting the value you will be get this expression is 0. Since these are 0, so you can say easily these two are orthogonal to each other. Go to the next question. 3.17 says, suppose the potential is a constant V0 over a surface of sphere. This is a case of the sphere. The potential of the surface of the sphere is constant. Use the result of exercise 3.6 and 3.7. Find the potential inside and outside the sphere. Of course, you know the answer are advanced, but it is just satisfied. So, from equation 3.66 in this section, you can see this is the potential inside, that is R less than R, that is sorry, R less than R. Then you can easily say this expression of the potential expression which already obtained in this book in equation 3.66. Okay, where L is the like this expression 2L plus 1 2 r to the power L 0 2 by V0 BL cos theta sin theta etc. Here this V0 is constant, so taken V0 as a out, the PL cos theta sin theta, and this is nothing but P0 cos theta sin theta, and you know this is 0 if L not equal to 0. When L equals to 0, this becomes 2. So finally you got this L equals to 0 if L not equal to 0, L not equals to 0, and when L equals to 0, this becomes V0. Clear? So finally we got that expression, that is potential. Here only L equals to 0 is present, others for other this coefficient is 0. So if you put the value L equals to 0 in this expression, that is the potential expression, only L equals to 0 value is exist, only 0 value is exist. So you will be get this expression, that is the potential inside the sphere, right? For in case of outside, this potential expression will be like that, that is equation 3.72, where BL equals to nothing but this expression. This is actually AL. You can also use this expression of AL. You can find the same thing. So in case L not equals to 0, this becomes 0. For L equals to 0, RV0. So put the value L equals to 0 in this expression, that is B in this expression for outer case equals to putting this value, sorry, I think there is mismatch. Okay, so put this value, you will be get the value of L. From that you will be get the value of potential. Clear? This is case inside and this is for outside. Okay, now the question, the next question says, find the potential inside outside spherical cell carrying uniform surface charge density of sigma 0. So this is the expression for inside potential, this is the outside potential, where BL and AL are connected like that, and this AL can be calculated using this formula, and the similar pattern just follow up. You will be get this expression of AL. After getting the expression of AL, you will be get the potential, and the total charge will be like that. So you can total in terms of total charge you can express sorry this expression. Okay, problem 3.18 says the potential at the surface of a sphere is given here. So here the potential is not constant, this is a function of theta. Find the potential inside outside sphere as the surface density sigma of the as well as for the surface density of this sphere. So since this is this can be written in the cubic form, since this is a third order polynomial, so there must be a list is the P3, and this is a odd function, this is a odd function, so this will be combination of P1 and P3. So if you relate this with the P1 and P2 and just compare in the both side, put linear combination means alpha into this is P3, this is P1, right, and put this value P3 and P1. Oh, sorry. P3 and P2, and just compared with the coefficient of cos q, and this is the coefficient of cos, so you will get this expression. Okay, so finally you will be got this v0 as like that in terms of polynomial. So in terms of p, this v equal to like that in terms of p. So from equation this is bl, and al you put the value of this in terms of p, you can write there, and this is nothing but the formula of this. Okay, for legendary polynomial, so this is the orthogonality property of the legendary polynomial. Put this expression, and this is delta L3, this is delta L1. So this become when L equals to 3, this is 1 and this is 0, and for L equals to 1 this is 1, otherwise this is 0. So put this value, you will get this expression. Go to the next question. Sorry, after putting the value of al you will be get the value of bl. We'll just put this value when l equals to 3 and l equals to 1, these are present, otherwise this will give the 0 value. For l less than r, so vr will be this expression with respect to al. Just put this value of al, because we got the value of al, you will be get this expression. In case of inside, in case of outside, put the similar of the bl value, you will be get this expression, and the corresponding surface charge density will be like that. Okay, just to do throughout the expression, just calculation, you will be get this result. Next question says 3.19 says that is, suppose a potential v0 of the at the surface of the sphere is specified and there is no charge inside and outside sphere, so that the charge density on the sphere is given by this. So from equation 3.81, sigma theta is like that at a, where al equals to this. So this, if you put the value of al in this expression, you will get this equation, and if you take this as a cl, the other part of this portion, other part of this portion you can take as a cl, where cl equals to like that. So this is the same thing, or this we put like. I think clear. If there is any doubt, you must comment in the comment box. Okay, and check the calculation, where any mismatch or miscalculation, you must comment in the comment box. Okay, so just look into this and do the calculation yourself. At any point, if you there is any doubt, you must contact with me. So this is all about me. This is my contact details. This is my YouTube channel details. Go to this channel, you'll be get other video like with the of the physics. Like this session and share this video to your friends, so that he or she also get benefit from this video. Subscribe this channel if you new in this channel. Those already subscribed, thanks for subscription. Press the bell icon to get the notification of upcoming video. So in the next video, we want to discuss the next question series of this book, that is Electrodynamics by DJ Griffiths. So take care. We'll meet in the next video as soon as possible. Thank you.